This has been long pending. Let us start completing this part now. So far we have covered on how two mobile phones will be registered with the IMS network here by using the register procedure. And now we need to see IMS call that is getting established between these two components. So we have invite originated from one user. Um, so user 1 is originating it to user 11. So these are the actual two guys who have been registered with the IMS environment. And this is the invite method, and the details are provided, like content length related information is sent. Okay, and this information that we have packed into SIP. SIP is packed into UDP. UDP is into IP. Source IP address is user one's IP address. Destination IP address is going to be PCSCF, proxy CSCF's IP address. And because we are studying this log file between eNodeB to S gateway, we see these IP packets packed inside the GTPU tunnel, and we have an external UDP, then that is packed into the external IP packet. For this external IP packet, source IP address is eNodeB, destination IP address is S gateway. So once we send this, what happens? Once we send this, there is 100 trying that is coming back from the other side. So 100 trying is a provisional response arriving from 10.0.0.100 to 10.255.1.1. You can see that addresses are opposite. So the proxy component is immediately sending back a provisional response called as 100 trying. It is sending. So this is generated as a reply for your invite method. That's great. So if we minimize this as well, now what are we doing? Now the message is being sent from the same invite method is being sent from 10.0.0.100 to 10.255.1.111. 10.255.1.11 1.1 is the IP address of one of the mobile user. The other mobile user's IP address is 1.11. So now the invite method is being it is actually one mobile user have sent the invite method to proxy CSCF. Proxy would have forwarded to SCSCF. SCSCF would have found out the IP address of the other user and sent that invite method to in the reverse direction back to proxy. So this is proxy, this is proxy. Actually, both the proxies are same guys. And okay, better way of drawing that. It's not like this. So instead of drawing it this way, we can draw it this way. So one mobile user, we have a proxy CSCF and we have a SCSCF. And this guy sent a invite method to proxy. Proxy immediately sent him on a trying. And from proxy, we are sending the invite method to the SCSCF. SCSCF found the IP address of the other guy. And after finding the IP address of the other guy, yes, sent the invite method to proxy again by using those IP address related details inside the invite method. Now the proxy need to forward this to the other mobile user. Here we have two mobiles operating. The guy who is initiating the call, that guy's IP address is 10.255.1.1, and the proxy's IP address is 10.0.0.100. We don't know the IP address of SCSCF. It's none of our business. So we are only seeing the traffic that is getting exchanged between the mobile to proxy, proxy to the mobile. This other mobile's IP address is 10.255.1.11, the IP address to this other mobile. So invite is going here, the invite is forwarded here, and then the invite is, yes, what is it? So we have the another invite here that is generated by S to P. P is sending that finally to the mobile user. So the invite is arriving here. So that's the direction in which it is operating. So this invite method, okay, there is a question why we need to perform the authentication and the security mechanism in IMS if we already done the authentication at the time of LTE time, because LTE will be considered as only access. If you remember my um, document that we have studied, like the VoLTE IMS part, I will go back. In order to get the access connectivity, you need to prove yourself genuinity to access technology by performing the authentication. And once you prove you are a genuine guy, you will be able to access the IP network with which you can reach your IMS technology components. Then to get your multimedia services that you have subscribed, you again have to authenticate with the IMS network, because IMS network is never aware whether the user has completed the authentication in the access technology or not. For example, without using a LTE network, as we can also use any access technology network. For example, we could use, let us suppose we could use non-LTE technology network to get IP access, like internet connectivity, or you can use any other technology, Wi-Fi, etc. So in such cases, those technologies will be doing the authentication only to give you the access permission to connect to the Wi-Fi network. You need to complete the authentication with Wi-Fi. To connect with your internet connection, you need to authenticate with your internet service provider. So you are doing that authentication only to get the service to be able to connect it to IP. But once you have IP connectivity, you with which you will reach your IMS network. From IMS network, you have to again authenticate with IMS network for the purpose of getting the services. Like what kind of services that you would like to get. IMS is authenticating to provide you the services. Okay. Um, so that's the core idea behind it. And yeah, the invite method is being forwarded from um, PCSCF to the other mobile user. So you can see the invite. Uh, all the message header details will be there. UDP, IP, GTPU, UDP, and here source IP address is S gateway, destination IP address is E node B. In the reverse direction, it is arriving at E node B, this IP packet, external IP packet. Inside that, internal IP packet carrying the SIP message. Now, once this SIP message arrives at um, the user 11, so user 1 is making a call to user 11. What is that user 11 doing? User 11's IP address is 10.255.1.11. It is sending a provisional response message called as session progress. You may be worried about what the hell is this session progress? What is even the meaning of this session progress? 111 is reporting to the proxy that, hey proxy, listen to me carefully. I am just acknowledging back that I have received the invite method and I am reporting you back with a 183 session progress. That means session has been progressed, but the phone is not yet ringing. Um, why it is why 183 is different from 180 ringing? 180 ringing means the phone is already ringing. But this is not equivalent to that. This is session progress. What is the meaning of session progress? Um, in case of LTE communications, In order to establish a, packet voice call, we must have the resources allocated for your packet data transfer. You require the resources to be allocated. In terms of LTE technology, we call them as bearers, EPS bearers. So we must upgrade the mobile user. Right now, the mobile may be having only a default bearer with which it is making the VoIP call or Vivo LTE or the IMS call that we are studying right now. But we must be upgrading the user from that VoIP signaling message sending on the default bearer to dedicated bearer to send your voice traffic. But because the dedicated bearers are not yet established, your mobile equipment is sending only a provisional response saying that I could have proceeded further and like triggered the message, triggered the ringing, but if I ring it, the mobile user will pick up the call. Once that is picked up, he starts speaking. To send the voice data, we require a dedicated EPS bearer, which is not created. That is why I'm sending this 183 session progress. It comes from 111, the user who is receiving this SIP call, to the proxy. And the same session progress is getting forwarded from proxy to the user who originated it. So this session progress travels all the way across from the guy who received the SIP call related invite method successfully to the guy who originated the invite method. The 183 session progress happened. Uh, Now 183 is called as a provisional response. It is not called as a final response. Every provisional response can be acknowledged. So provisional responses can be acknowledged by using a mechanism called as PRAC, provisional ACK. So the 1.1 who received this session progress message is sending a acknowledgement for this provisional response in the form of PRAC. It is sending this to proxy, and proxy is now forwarding it towards the other mobile who originated this 183 session progress message, for whom we have sent the acknowledgement. Your final responses would be acknowledged with the ACK message, whereas provisional responses will be acknowledged with the PRAC message, representing the provisional acknowledgement. With these two steps that are getting exchanged between the mobile phones, we can conclude that uh, the SIP session has been reached the other side as well. That guy responded back, and you got to know about that information. Now, at this stage, um, what will actually happen after this session progress and PRAC? Once this is done, your PCSEF component will actually go and communicate with after this session progress and PRAC. PCSEF component will go and talk to your PCRF component. Okay, explaining him by using this interface called as RX interface. Explain the PCRF that what kind of a quality of service is required for this voice data for these two users. And PCRF explain those details to P gateway, and P gateway will communicate that information to S gateway, whatever the quality of service details. Once he got to know the quality of service information and corresponding billing details, P gateway starts a procedure called as create bearer request. To create a dedicated bearer, it starts this create bearer request message that comes to S gateway. S gateway triggers it towards the MME create bearer request, and MME will start sending a message to eNode B called as ERAB setup request to create the dedicated EPS bearer. So we'll be triggering that ERAB setup request for the purpose of sending the voice data. We require this ERAB. So we are having this ERAB setup request in here. So because we are not studying the log file on any of these interfaces, so PCSCF to PCRF communication we cannot see. RX interface, we cannot see the communication happening between PCRF to P gateway, the GX interface. All these messages we cannot see. Even we can't see the information between P gateway to S gateway, which is create bearer request, or even on S11 interface, we have the same create bearer request message. Even that we cannot see. But we have to imagine all these steps are happening because we will be seeing this ERAP setup request message here right now. So you have a ERAP setup request message, and that is getting created from MME 10112 is your MME 101 10121 to 10 is eNode B. We are asking eNode B to create the ERAB, which is radio bearer plus S1 bearer. Of course, P gateway to S gateway, already the bearer would have been created because it is the P gateway who is initializing this dedicated bearer creation when it gets the instruction from PCRF. So once this ERAB setup request is sent, which is a S1 protocol message, uh, this is for which user? This is for a user whose IMSI ID is something. For example, MMEUES1 API ID of that user is 1. MMES eNode B UES1 API ID is 0. But for the second ERAP setup request message, MMES1 API UEID is 0, eNode B UES1 API ID is 10. So we have two users whose IDs are different. So for both the users, MME is starting ERAP setup request. So because both the guys must be upgraded to the traffic channels, nothing but your dedicated EPS bearer. Then only we could exchange the user traffic. And you have ERAP setup response um, for one user, and immediately subsequently you have another ERAP setup response as well for the other user also. So we have two ERAP setup responses. So once we have these two ERAP setup responses, now we know that both the guys um, dedicated bearers have been created and they have been activated, and the activation has been accepted as well. That is coming in the form of a NAS message, and you can see the feature of SCTP here called as message bundling. SCTP is bundling at least one, two, three messages together. Here we have only one message in the SCTP, one S1AP message, which definitely is your successful response for the one ERAP setup. The other one is this is an uplink NAS transport, which is the activation of acceptance, your dedicated bearer activation acceptance message, and there is one more S1AP message, which is successful outcome for the ERAP setup response. And the next message is uplink NAS transport, which is again accepting the activation of the dedicated EPS bearer for the second guy. So these three messages, as their messages are very small, S1AP, SCTP is bundling those messages and sending it from eNode B to MME all at a time. So that is the exact feature we liked about SCTP, and we are using SCTP transport mechanism between eNode B to MME. So with this ERAP setup responses and the activation of the dedicated bearer accepted for both the mobiles, now we can say that their resources have been created, their dedicated bearer resources have been created successfully. So once the dedicated bearer resources are created, one guy, actually these are in a zigzag fashion, but you have to somehow change the order in the correct way. So I'm explaining you this 200 OK. So the guy who is receiving the incoming call is 1.11 guy. He is picking up the call and it is sending a SIP acceptance of the call by sending 200 OK. So the call starts ringing and he picked up the call and it is 200 OK. And in the 200 OK, it is sending the content information. Actually, the content information is not shown here, but anyway, if you see the content information, what will be there is this guy's user plane IP address and the port number details will be present inside this 200 OK status. So whatever that is moving from user 11 to the proxy, the same thing will be sent from proxy to user 1. 200 OK has been forwarded. So with that, the call has been picked up. The call has been picked up, and meanwhile, their dedicated bearer has been activated as well so far. Okay, so once the dedicated bearer is activated, you will be having an update procedure also. What is this uh, update? And what is this update about? This update is about the resource acquisition is completed. It is about the resource status. So if you open this information, in that actually you will be able to see the details, but here you cannot. But let me tell you that this update is about explaining that it is the resources for that mobile is created. So 10.255.1.1 is reporting to the proxy server that my resources have been created, and similarly the same update is being now forwarded to the other side as well. So proxy is sending it to the other user, this update message that the resources are created and you are ready to um, go to the next step. Even though there are 200 OK messages are sent earlier from 10.255.111 to 100 and 10.0.0.100 to 1.1, these 200 OK messages are not your call related OK. As you can see these two OKs now, these are the response for your provisional acknowledgement messages, because your provisional acts will be responded back sometimes with the 200 OK. So earlier I did not observe that. So I'm telling you now that these are actually for PR ACK. These 200 OKs are not for call establishment. So these are for these PR ACK OK. So the other guy has sent PR ACK and you are sending OK. That OK is traveling on to the other side as well. But these are not for call establishment. First the resources are getting created. Once the resources are created, that resource related update is taking place. This update procedure will inform between one component to other component that the resources have been created, user plane resources has been created, and it is the time for you to accept the call. So once the update travels all across the path 1.1 to 100 and 100 to 111, then the 111 guy who is receiving the incoming call, then it is sending a 200 OK for this update. Hey, thank you for sending me this update, man. Even I am I am informing you that even my side also the resources are up. The same update to acknowledge OK, 200 OK, because update is a procedure. 200 OK will be sent as a response to that procedure. So this 200 OK, which is going from 111 to 100, that is again traveling from 100 to 1.1, the OK message for this update procedure. Once this is done, then the actual call related activity is getting triggered. What is the call related activity? The phone starts ringing on 111. So it is reporting that my phone is ringing by sending another provisional response called as 180 ringing, that comes from 111 to 100, that is from the SIP device, the mobile phone, to proxy. Proxy is sending it to the other user, the ringing message. With the ringing message, you know that the phone is ringing. Now it is the time for the other guy to pick up the call. Wherever it is ringing, that guy need to pick up the call. But because this 180 ringing is going to be considered as a provisional response, so we have a PR ACK for that provisional response message that we have received. So this is for this PR ACK is for the ringing method that we are sending, and it will be going from 1.1 to 100, 100 to 111. For this PR ACK, again, there will be a 200 OK. So this 200 OK is for PR ACK. So Your PRAC will have 200 OK from 111 to 100, then 100 to 1.1. So you have this PRAC related 200 OK. So um, 180 for 180 ringing, there is a PRAC. For responding back to PRAC, we have another 200 OK message. But finally, the phone that is ringing on 111, now it has been picked up. The call has been picked up. Now that is 200 OK for the invite method. That means the call has been picked up by the 111 guy. So he is reporting that I have picked up the call. It is going from 111 to 100, which is the proxy, and now proxy is forwarding the same invite related 200 OK message to 1.1, that is to the mobile user who initiated the call. With this, we can say that the call is call has been accepted by the guy who is receiving the call. But for 200 OK messages, we'll have a acknowledgement. This acknowledgement is for your 200 OK message. Every time we have a final response, we need to have a acknowledgement for the final response. So this ACK is for the final response, arriving from 1.1 to 100, 100 to 111. So with that step, the call has been established. So we can say that the um, IMS call has been established here. So and then user traffic starts. So the RTP data is the user traffic. So 43 bytes is the voice traffic packed into UDP IP. Source IP address is 10.255.1.1. Destination IP address is 10.0.0.100. We are sending the RTP traffic to your proxy, and then from proxy to the other side. So it is going from enode B to that guy, and again it will be coming in the reverse direction. So if proxy's IP address is used as a mediating IP address for the user data, we will consider the proxy acting as a ALG component. If I hope you guys remember the concept of ALG component, application level layer gateway, to store a copy of all the voice data that is getting exchanged between the users, especially in case government orders that all the calls must be recorded, or some sort of a thing like that. The call data won't be directly traveling from one mobile's IP address to other mobile's IP address. Instead, it will be traveling. It will be traveling through um, the proxy. So that is why we see the IP addresses not direct. Otherwise, we would have seen the source IP address as 1.1, destination IP address for the IP packet is going to be 1.11 if the RTP traffic travels directly. But here we can see that the voice traffic is not traveling directly. It's not even using RTP, it is directly actually packed the data inside UDP GTP. So there is this RTCP traffic also exchanging sender report and receiver reports.
Excuse me, sir.
Yeah. Yeah.
Sir, why for one prac, 200 OK messages are sent?
No, it is not.
Sir, above. It will go up.
Okay, I'll summarize
Will
the
go
whole
up.
thing again once again.
Where for
So
the prac to be
understood that. Let me go back. Um, okay, let us look into these things clearly. This is the full call flow. I'm explaining it. Just listen to this carefully. 1.1 invite method is getting generated to proxy. So this is the uh, user one who is sending it to proxy, and proxy is sending that to user two. So this is the user two guy. Okay, sorry, that is wrong again. Mistake. Like let us take this is the user one. This is the proxy, and proxy is sending a 100 trying. Let us leave that 100 trying. If you look into the next message, this is the invite method going from proxy to user 2. So this guy is the user 2, invite message forwarded. The user 2 has sent a 183 session progress. So this is the user 2 sending it to proxy. Which message? Session progress. But proxy is not the reception component here. Proxy is a mediator always. So proxy need to forward the same 183 session progress message to user 1. So the 183 session progress generated by user 2 sent to proxy, proxy to user 1. Next, this 183 session progress must be replied back by the user 1 who received this 183 session progress. So the user 1 generating your PRAC, and that is sent to proxy, and proxy is forwarding that PRAC to user 2. So this is the user 2 guy. So who generated the PRAC? User 1 generated the PRAC sent to proxy. Proxy is forwarding it to user 2. Now once this is done, these PRACs must be the PRAC generated by 1 which is sent to 2. 2 must reply back with 200 OK. So the 2 guy is sending the 200 OK message for receiving this PRAC to proxy. So this 200 OK is a response for the PRAC. So 2 is sending it to proxy. Proxy is sending it to the user 1. So it is that if you actually see the whole logic over here, this is 1 to 2. Sorry, here if you see 183 progress, this is 2 to 1, and this is 1 to 2, and this is 2 to 1. So there are totally 3 messages exchanged. 183 session progress, further the response is PRAC, further the response is 200 OK. Is that clear?
Sir,
Up to here.
if you'll come down little, yeah, this much is clear.
I'll come
Sorry.
to that. I'll come down. Let us wait.
Sorry.
Let
Yes,
us wait.
yes, yes.
Okay. So now the ERAB requests are happened, the resources are created. So these 4 statements are related to resource creation for 2 mobile phones. So the ERABs have been created. That means also S1 bearers would be created, S5, S8 bearers would be created, and you are creating the dedicated bearer required, dedicated EPS bearer, and the user's resources have been created. Once the user's resources are created, the user 1 is initiating an update message to proxy to tell him that, hey man, I'm telling you that my resources are up right now. And proxy is forwarding the same information to the user 2, that the user 1's resources are up right now. And by acknowledging that this update message in this OK, user 2 is also going to explain to proxy. With the help of proxy, it will be sending it for this message. Actually, order is a little changed here. Proxy to user 1 by sending this 200 OK message to this update message, the user 2 will report that yes, on my side also the resources are up. So one guy sends the update, the other guy is sending the 200 OK to say that yes, I am done with that. My side resources are also up. So once this is completed, now the user 2 side phone is ringing. So it is generating a message ringing tone. It is coming from 2 to proxy, and proxy is sending the response back to user 1 that the phone is ringing. So this 180 ringing is coming from second user to proxy, proxy to the first user. So first user understands that the phone is ringing. This phone ringing, 180 ringing is called as a provisional response. Provisional response must be can be provisionally acknowledged. So for acknowledging that provisionally, the guy who receiving it is 1. So 1 is replying back with this PRAC. So 1 is sending it to proxy. Proxy is forwarding it to user 2. That because you have sent me ringing message, I am sending PRAC. But PRAC need to be responded back with a 200 message. That is how it works, because PRAC will be considered as a method in its own merit. Methods must be responded back with the responses. So PRAC method will be responded back with 200 OK message. So this 200 OK message is getting generated by the user 2 as a response to this PRAC, this 200 OK message. This is coming from 2 to proxy, and here proxy is sending it to user 1. So 2 to proxy, proxy to user 1. It is going in. After that is done, Then this 200 OK is the call lifting for this invite method. This 200 OK is call lifting for the invite method because the phone is already ringing right now. That should be picked up. The moment the call is picked up, the user 2 who is picking up the call will send 200 OK message to the proxy. Proxy will forward that to user 1, telling him that the call has been picked up. That is this 200 OK. So this 200 OK and 200 OK are for this invite method, not for PRAC. We are not sending it two times. This 200 OK is for the invite part, the call that is initiated. And for this 200 OK, where the call is accepted, for the 200 OK method, we need to send the acknowledgements. So this is the acknowledgement by the user 1 to proxy, and this is going from proxy to user 2, the acknowledgement for this 200 OK. Are you guys clear now?
Got it, sir. Sir, why this order is getting changed if the flow
Little
is
amount of
something different in real time?
nothing, no different flow, nothing. It is simply our perception. What is happening? This particular, if you look at this two messages over here, this is originated by the user 2. User 2 sent 200 OK message here for PRAC, and the phone is already ringing by then. He is sending this 200 OK for PRAC message that is received. So it is sent this. Meanwhile, the guy picked up the call. It immediately generated this message also. The two guy has generated two 200 OKs. One 200 OK is for PRAC, one 200 OK because he's picking up the call. Because two messages are generated, both the messages come to the proxy, and proxy is sending both the messages one by one in the same order to first guy. You see? Both are independent things, procedures. Both can happen one by one immediately. It is not that hey, you have to wait till this 200 OK goes to the other guy, then only you have to generate this 200 OK. There is no such rule. It can immediately generate the 200 OK as well. So that is what is happening here. That is why you are seeing little order changes here. But other than that, there are no much order changes in the actual full log. Only our perception of order change. But in reality, this is how it works out. If they apply little amount of time, then all this thing won't be there. Okay. If you summarize it, um, invite provisional response. For that, we are using PRAC. The PRAC must be okayed. Then we have to create resources at LTE level to create the dedicated bearer. After that is done, we will perform update, and for that update, we will be doing 200 OK, and then another provisional response called as ringing, and that provisional response we have PRAC. For that PRAC, we are having 200 OK, and after that, because the phone is ringing, it will be picked up with 200 OK. And for this 200 OK, you need to send acknowledgement. With that, the call is got established. So these many steps we have in total. So how the call termination takes place? So first is SIP level, the call will be terminated. So the guy who is 1.1, the guy who made the call, it is sending a buy message to 100. 100 is forwarding that to 111. But we know already, buy is for terminating a SIP session, and buy will be responded back with 200 OK. So once the 200 OK is done, then 10.1.2.10, which is the MME, reporting it to Enode B that um, or this is to be reporting it to MME that there is a uplink NAS transport message, bearer resource modification request, explaining that I don't need this bearer right now, or you might be reporting that the bearer is become empty, it is not transporting any data. So you might be reporting that non-access stratum. So um, traffic flow aggregate, we will see the traffic flow aggregate here. Um, so you see um, delete packet filters for existing TFT. So you're basically reporting that this can be deleted. It is basically stopped. So we don't have any data going on anymore. So that's the end of it. We are reporting. So once that is reported, we are releasing the ERAP that is created, and from other mobile also we are receiving this same thing, and towards that also ERAP is been released, and we have got ERAP release response, ERAP release response, and whenever there are no messages on GTP, it will be echo request, echo response, and if the users send a detach request, you will be accepting it and you will be deleting the UE context, and the mobile users will be moving into idle state after releasing their UE context. So we have released the IMS call, and we have also moved the mobile users, both mobile users, into idle state by releasing their resources and by detaching them. Okay, so those are the messages that have been exchanged. I hope the call is clear for you here in total. The UE to UE Vivo IPC IMS call, basically it is IMS call, IP call. Okay. We study much more calls, but before we study much more calls, we need to complete the introduction of the remaining components in LTE infrastructure. We need to complete that. So we'll be looking into that aspects here. So we have the UE, we have the PCSCF and SCSCF. So UEs will be registering with the SCSCF, and SCSCF will be gathering authentication related kind of details from HSS and authenticate the user to validate whether he is a actual subscribed IMS user or not. If he is proved to be a proper IMS user, then SCSCF will allow his services. Now, I'm going to tell you the example that we have studied is a call between one user who is registered with SCSCF, other user who is registered with SCSCF. We have established the call between this guy to this guy. So that is what we have done. We have not involved any application servers here, because the call is this user is considered as user agent client. This user will be considered as user agent server, and these guys are either acting as the proxies and registers, helping the call details to be sent from one user to other user, as these guys know the IP addresses of the users. That information is stored in your register component. But when these application servers will come into play, when this application server comes into play, that's easy. For example, if this guy is making a SIP session with his in the from is using his SIP URI in the from, and application server's SIP URI in the to, if it uses, that SIP session invite method will come to SCSCF. SCSCF, with already acquired information received from the HSS, SCSCF will determine whether this invite method must be allowed or not allowed, whether this mobile user has subscribed for this particular application server services or not. If there are 20 application servers, if UE is subscribed only for 10, instead of requesting any of those 10 application server services, if this UE is requesting for any other service, then it would be sending that information to when the invite method is sent to SCSCF, SCSCF would be replying back to UE and telling the uh, telling the UE that um, telling the UE that it is not allowed. Your SIP session invite method has been rejected because you are not allowed to be connected to that application server services. So operator might bring up lot of services in the form of application servers there. If you go to Reliance Jio My Jio app, you might find like 20, 30 apps in the Reliance Jio app. Uh, what are all those apps? Maybe all those apps are connecting you to one server. So those are the different application servers that have been brought up in IMS environment in Reliance Jio network. So if you open one app, you will be connected to one application server, and your mobile will be generating a sip and write method whenever you open that app, and it will be using um, your own mobile phone's SIP URI as the from address, and whichever application you are opening, that application itself will have a SIP URI. That SIP URI will be there in the to address, and that SIP invite method would be sent to SCSCF. SCSCF will decide whether this service must be accepted or rejected. If he decides to reject it, it'll send um, 413 rejected service, or maybe there is 403, you did not pay money for that, or any such kind of errors it can quote and reject that invite method. So here all you just have to imagine that irrespective of how many number of application servers are going to be present in your operator's environment, um, all application servers will typically have a SIP URI, which must be quoted by the mobile. Somehow your mobile will get to know what is that SIP URI you have to use in the to address. So with the help of it, you will be able to generate SIP and write method. So let us suppose that we never need to find out SCSCF's location from DNS server. Uh, by PCSCF, yes, it could be. PCSCF has got, there are a lot of discussion on how PCSCF will find SCSCF's address. That information might be stored in PCSCF by the operator also. We don't much bother or care much on that operator's implementation of how PCSCF will be finding out um, you know SCSCF's address. P will never communicate with HSS. So you can all interfaces that are allowed, you see in the black lines, the dotted lines or whatever, you see those lines already. So if you sent an invite method to play a game, the game is being played in the game is being hosted in the application server. So what does application server do? Once this SIP invite method is forwarded to application server, this guy has no right to reject it. Typically, it will be accepting it by including the multimedia session related parameters in the form of SDP. When UE is generating a invite method, UE will be including SDP information, session description protocol. In the session description protocol, instead of having voice call related details, mobile equipment will be quoting the game related information inside, the game related multimedia parameters. It will be including because he is going to play a game. So SIP is going to contain the invite method. SIP's major duty is to establish a session. From address is mobile, destination address is application server, but the application is of type game right now. The gaming related details will be packed into SDP. Earlier, when one mobile and other mobile are establishing a voice call, their voice call related multimedia parameters are packed into SDP when they are establishing a VoIP SIP call between among them. That is the earlier scenario. But now in this case, it is going to include gaming related information in SDP. Once this invite method goes all the way up to application server, it generates the reply, sends the reply back to SCSCF by including the accepted SDP parameters on the gaming server side, and that message will come to UE, and it will be 200 okay. This guy will be sending acknowledgement. We can say that SIP session got established between UE and application server. As part of the SIP session establishment, UE's IP address might have been known to application server. Application server IP address might be known to UE. Once they got to know each other's IP address, they would be exchanging this game related traffic directly on a user interface. This UT interface is a user traffic interface where you will be sending the UDP IP RTP traffic or your gaming traffic, or it could be, for example, if the application server is a movie server, you decided to watch a movie, and you know depending on the quality of service that you have requested, like 480 pixel movie you wanted or 1080 pixels you wanted, whatever that you have requested, the corresponding thing is being accepted by this guy. So this pixel rate etc will be packed into SDP information, what kind of a movie that you want to watch. That is session description protocol. Once that request is sent to application server starts sending that movie traffic in the downlink direction. The video would be coming in the form of IP packets to your mobile, and your mobile starts playing that movie. Okay, so that would be direct. So there can be a session established between one user to application server as well. We can establish a session between these two guys as well. So session establishment must happen through P to S to the application server, and in the reverse direction. These are the signaling call flow. User data typically will be direct between application server to UE, because each other find out their IP addresses. They can exchange the traffic directly. Okay. So now we are understanding what is the meaning of these application servers. So if it is the voice calls or any such things that mobile is initiating in IMS environment, then we have to go through P and S. Um, we have to go through P and S, definitely. Um, so what would happen when it is going through the P and S part? So these guys validating it and accepting the service. So you're not directly reaching the application server. You should go through these components. Okay. Now, what is the role of this SLF component? What is this SLF and what do we use this SLF for? Stands for selection function, basically. Um, the purpose of this selection function is to select a HSS whenever multiple HSS are present who are storing the subscriber details. If any component who would like to find out a subscriber details, if they wanted to ask the subscriber details from HSS, if they don't know which mobile users or which IMS users subscription details are available with which HSS, especially in an environment where multiple HSS are present, you require this SLF component. If your operator's IMS network is containing a single HSS, you don't need this SLF function. When you obviously any request you receive for any user, you will be asking it from that single HSS itself. But if the your IMS company's IMS infrastructure is containing multiple HSS, then you will have to go and talk to the SLF to find out this particular user's details will be available with which HSS. Then you will forward it. For example, if UE sent a register method to SCSF, SCSF don't know these guys, these particular users who initiated this register method. These guys information is not known to SCSF. For example, let us take it that way. What does SCSF do if it doesn't know the details are available with which HSS? So then it will be questioning the SLF. Hey, it's SLF, tell me one thing. There are a lot of HSS present in our operator environment. So which HSS is storing this particular user's details by quoting the SIP URI? We'll ask him SIP URI or IMP or IMPU, one of the IMS user IDs. So this guy will reply back, this guy's details must be available with so and so HSS. Then SCSCF would be forwarding that information to HSS. Again, SCSCF to HSS, the protocol that we'll be using is diameter. We know that all diameter protocol stacks will be working with DRS in the middle. So both these components, HSS and SLF, both operate on diameter protocol. So these any component which are interacting with these two components, HSS and SLF, must be using the diameter protocol stack. It could be any component. It doesn't matter which component it is. So how many components are communicating with
Hello.
that's wrong.
This is common for IMS and conventional net for both.
Rahul, I'm losing your voice.
Hello.
Yeah,
Sir, am I audible? Sir, this access is common for IMS network and conventional 4G network for
it could
both,
be common. It could be common, but
or
the tables will be different. IMS information tables that are present in HSS. Basically, HSS is a database which is SQL data, MySQL database or something where all the information will be stored in the form of tables. So the tables will be different. So LTE tables will be containing LTE subscription related information, like how many packet data networks the mobile equipment is subscribed, for which packet data network, what is the data rate that is applicable, etc., etc. Those details will be stored in for MME's purpose. The same HSS in another partition in the form of some other tables, it will be storing the information related to IMS subscriptions, which and all application services the mobile user have subscribed for IMS network. Those details will be available in the HSS. It could be a single HSS which is maintaining the information for both access technology as well as IMS service technology.
and how many such IMS network can be there in any network, like in Andhra circle if we consider Andhra Airtel. So how many IMS network can be there? Like there can be MME can be there two or three depending on load in that circle. So such how many IMS network can be there in any circle?
That's actually not at all a relevant question at all. How many IMS networks is typically be operator determined factor. There is no such rules. This is the same question I'm getting like from starting day one, but answer is obviously the same answer. I think I've answered the same question in many batches throughout the years in the same way. These things are not prescribed by 3GPP. That is my standard answer. You can answer that answer yourself. It is not going to be anything dependent on 3GPP. Never decide that how many IMS networks you want to bring and implement it. That is your choice, depending on the capacity of these components and how you are bringing up this environment, etc., etc. It all depends on that. But when you take it to one circle as a standard area, you never need to maintain more than one IMS network. Of course, you need to maintain many PCSCFs, many SCSCFs, and many ICSCF components in order to take load management, or in order to have higher load. You can take higher number of these components. We can increase these components, PCSCF, SCSCF, ICSCF. No need to be only single component need to be there. There could be many PCSCF, then it could be many SCSCFs, there could be many ICSCFs in a IMS environment. Or for that matter, any components can be any number. So the IMS network would be single, and none of the operators will bring additional IMS, buy additional IMS domains unnecessarily, pay the free money to IANA to bring up a new IMS domain name, and uh, pay more money, like 10 million more every year they will be paying it to IANA just because they have got lot of money in their banks. Simply they don't want the bloody money, and they want to transfer the money to some company in the world so that they will become poor. So none of the companies will think that way. So typically, whenever you can maintain a separate network for a circle, you will be maintaining only one IMS network per circle. That's how you do it. But it could be like full countrywide also. You can have one IMS network itself. Like it's at the starting, Reliance Jio has done that. Later, when Try put the regulations that it should not be done or whatever, then they have actually changed their architecture circle wise. Okay, but it's your choice. It's the operator's implementation. So 3GPP never decides that. This is same thing like our capacity question. How many users eNodeB supports? How many users MME supports? So these kind of questions, these how many questions, all answers are same. There is no answer for that. It is all implementation basis. Okay. So how many components are communicating with this HSS and SLF units? SCSF. So S will, by using diameter protocol, it communicates with SLF, find out about HSS details, go and talk to HSS and get the user subscription information. That is SCSF. Then why application server will be contacting SLF and HSS? I'll explain that also to you. Let us take this case. There are two UEs. This UE decided to play a game with this user. The gaming server is this application server. So this guy generated, this guy opened the gaming application and decided to send a request to this mobile user. He decided to send a request. When the invite method is generated and sent, it will be sent to application server. From address is this guy, to address is the application server. But in the SDP information of this message, you will have this mobile's um, SIP URI will be present, telling the application server that I want to play the game with this guy by keeping you as the mediator. So application server is going to act like a mediator here, and this fellow want to play a game with his friend. His friend's SIP URI is present in the SDP information. Once this guy is receives, application server receives that gaming request. Now this need to forward this invite method to the other user who is supposed to get this, who is supposed to play this game on the other side. So invite method must be sent to that UE. But application server don't know what is the IP address of this user, and this user is registered with which SCSCF. Especially as I told you, if your IMS network is containing multiple SCSCFs, to store the subscribers information belongs to a lot of users. So if one SCSCF capacity is not enough, we may bring a lot of SCSCFs. So application server don't know this end users is registered with which SCSCF. So application server would like to find it out. What does application server do? Application server goes and questions SLF. Okay, man, can you please tell me this particular UE's information is available with which HSS? So we'll ask this SLF. SLF reply back. Application server will go and question the HSS. Can you please let me know this particular mobile user is located in which SCSCF? I need to forward a SIP session towards that mobile. So then HSS replies back and tell that, oh, this guy's information is procured by this SCSCF. I know that this SCSCF is having that user's details. Then once that information is sent by application server will forward the call details to SCSCF. SCSCF, because this mobile user is already registered with SCSCF, SCSCF will pull out the IP address of this mobile and it will start sending that SIP invite method to this UE. In the SIP invite method, from address will be this fellow, to address will be this UE, and in the SDP information, this UE's information will be packed, explaining to this user that even though I'm sending the invite method to you, but this in the guy who is actually originating the gaming request to you is your friend. It is not generated from the application server, it is generated by your friend. So if you want to accept it, you can accept it. So once the call the SIP session has been accepted, 200 OK, acknowledgement, etc. These things are done. Then between these three guys, the user traffic will be exchanged between these three units. So UE will be sending the user traffic to application server directly. This UE also will be sending the data to application server directly. Application server will be deciding out of these two guys who is winning based on the actions that they are taking up. So application server can decide that user traffic will be sent that way. So in order to find out the subscribers are registered with which SCSCF, application server need to contact HSS. But when application server don't know, users details are available with which HSS, especially when multiple HSS are present in your IMS network. First it will contact SLF by using diameter stack, get the reply, then question the HSS. HSS will point out to you yes, then you will be forwarding it to yes, and from yes the call will be sent out. The invite method will be sent to the destination. Or, or what is this I stands for? ICSCF, interrogating CSCF. The primary purpose of the ICSCF is to receive the calls from external network. So there are two entry points for the IMS network. One entry point is through from the external places. One is from within your operator's network itself through PCSCF. For example, if these two mobile phones wanted to make a call who is registered with this yes, the call will be direct. It will go like this, it will go like this. We never need to involve I. Only we would be involving SCSCF, PCSCF, and at the time of registration, yes, need to be communicating with SLF, and then it may maximum communicate with HSS. If they are establishing any session by keeping any application server as a mediator, maximum they will be bringing the application servers also, and they will be exchanging the traffic with the help of the application server. That much will be happening. We will never be involving I. So when the I will be involved, what exactly is the role of the I and when I will be involved? When any call is coming from the external network, it will be arriving into a entry point called as I. First, it enters into the IMS network into I from the external network. So that means let us take that this IMS network is Reliance Jio IMS network, and Reliance Jio IMS network, and that too we take it as it belongs to AP. Now there is another IMS network which may be a Reliance Jio network itself, and which may belong to Mumbai. Now a Mumbai user has made a call, and that call details have arrived from P to S. It has first come to P to S. From that SCSCF decided that, hey, the from address is this mobile user's address. To address is pointing out to a Hyderabad user, Hyderabad IMS network user's address, to address. So it will use the DNS service, find out what is the ICSCF's IP address from the DNS server. So ICSCF addresses will be advertised in the DNS servers worldwide. So if you want to send any call to any IMS network in the world, you need to find out the IP address of ICSCF component of that IMS network. So once you find out the ICSCF's IP address of uh, Hyderabad IMS network, the call will be routed from this SCSCF. It will be routed to the ICSCF of the Hyderabad network. And once the call details arrive here, you will see the from is pointing out to the Mumbai user's SIP URI. There will be a two is pointing to the AP user's SIP URI. But first, yes, I wanted to find out this address guy who is available with the two, that two guy is registered with which yes, especially when multiple yes are present. I don't know mobile is registered with which yes. So what does I do when the call is arriving from some other network? First thing it does is go and talk to SLF, ask SLF, hey, so and so user with this SIP URI or the IMPU or IMPI, can you please tell me that the guy is, the details will be available with which HSS? SLF reply back, provide the HSS information, go to HSS, ask HSS that, can you please tell me the guy with this SIP URI in my invite methods to address, can you please tell me that guy is registered with which yes? And HSS replies back that guy is registered with the so and so yes. How do I know? At the time of registration, yes has procured the subscriber information from me, so I know it. So HSS will reply back to I. Then by taking that SCSCF's address information, ICSCF will be forwarding that call to SCSCF. This user who is receiving the call from a Mumbai user is already registered with yes. Yes, know the IP address of this mobile, and then it will be able to forward that call to this user. Are you guys getting it? Are you guys
So
understanding
this
it?
is
Yeah.
This also the same for other operator.
Sorry.
This is the same scenario for other operator also.
Yes,
Means like the
yes, yes,
Airtel.
yes. For example, you are making a call to let us take that you are a AP network and you are making a call to a Airtel network, for example, and you are a Reliance Jio network user. So this is Jio's IMS network. This is Airtel's IMS network. This guy is making a call with from address to address. Once the two address is read by the SCSF, it understood that the two address is pointing out to a Airtel user. It will go and question the DNS server. Hey, can you please tell me what is the Airtel's IMS network's ICSF address? You will question the DNS server. Once the DNS server comes back and replies, this SCSCF will be forwarding this call to the other IMS network on interface. You see this interface. Interface from the other network will come to our IA. Similarly, from our yes, the interface will be leading to the other IMS network. It will lead to I of the other IMS network. It is going to ICSCF component. Are you understanding? So this is coming from yes of the other IMS network. So if some Airtel user is making a call, from that Airtel mobile phone, the call will come to P. From P, it will come to yes. From it from P, it will come to yes, yes to our I. That is interface. Because the Airtel guy is making a call to Geo user. It arrives at Geo's I. I will question the SLF HSS, then forward it to yes. Yes, know the IP address of the user, it will forward the call details to that UA.
Sir, yeah, I have a doubt, sir. Sir, once the two mobiles knows each other IP address, after that, sir, intermediate nodes will be in play, or they will communicate
No,
directly
IP
with IP
address,
address.
if they, for example, if two UEs are having the IP address known to each other, only signaling might need to go through the yes. Um, Sometimes user data need to go to P if P is acting as a ALG component, as I told you already when I'm explaining the Wireshark log. So PCSF is configured as a ALG. UE traffic will be sent to ALG to the other user. PCSF will be maintaining one copy of the voice data that is getting exchanged between these two UEs, maybe to submit it to the government. In such cases, the traffic need to be sent through the ALG component. If this is not there, if ALG component requirement is not there, this UE's IP address will be provided to this guy in the SDP information. This guy's IP address will be provided to this guy in the SDP information. Once the call is established, they can exchange the voice traffic directly because both are already connected to IP networks. So they can exchange the IP packets with one another once they know each other's IP address by packing the voice data inside that IP packets indirectly, like voice into RTP, UDP IP. Source IP address is UE1, destination IP address is UE2. We can exchange the voice traffic directly between the users without involving any component. But if ALG component is uh, set as a mandatory for governmental organizational purposes or whatever, so you need to store a copy of the record, voice records, etc. Then the traffic would be sent to the ALG component and it goes back to the other user. A copy would be maintained there in the middle. The voice traffic would be maintained there in the middle.
Sir, here in this case, end-to-end voice traffic, who is taking care of the billing part? The direct traffic is going from one UA
Yes,
to
direct
second
means it
UA.
is going through LTE networks. Both the mobiles have got the IP addresses. How? I'll just um, let us take the two users. Um, okay, I will do one thing. I'll ignore this user. I will you take two other users. Let us take this mobile, and this mobile is making IMS calls. This guy is connected to one node B, S gateway, and then the P gateway. And this mobile is also connected to one node B, connected to a different S gateway, but the same P gateway. But when both these mobiles are creating the default bearer and connected to the IMS network, they both are reaching from P gateway to PCRF. So once they registers with the PDN, they will get IP addresses. So this guy get IP address from the P gateway. This guy gets IP address from a P gateway. So once they get the IP addresses, so you have the routers which are leading to PCSEF, and that's it. And let us suppose that this guy generated a voice packet. For this voice packet, source IP address is going to be this mobile's IP address. Destination IP address is going to be this mobile's IP address. What will happen to that IP packet? That IP packet will come to node B, node B to S gateway to P gateway. P gateway does the billing for this user. He will forward that IP packet to the router. Router will see the source IP address and destination IP address. Source IP address is one mobile, destination IP address is the other mobile. That other mobile's IP address is owned by P gateway itself. So what does the router do? Typically, it will revert back that IP packet back to the P gateway in the form of a downlink packet. The IP packet would be coming back to the P gateway itself. So P gateway understands that this IP packet is going to the other mobile. It does the IP packet billing for this guy as the downlink packet billing, and then it starts forwarding it to S gateway to E node B to the mobile user. So you will be sending that IP packet in the reverse direction. Okay, so we have reached our PDN, which is the router, the IMS based PDN, but that PDN's router is reverting the IP packet back, and it is coming back to the other user. We don't need to send this traffic to PCSEF until and unless PCSEF is acting as ALG. If PCSEF is acting as ALG, if this guy generates any voice packet, source IP address is going to be this fellow, destination IP address is going to the PCSEF address. And once the voice data arrives here, this guy receives that voice data, makes a copy of it. After that, it puts that voice packet into another IP packet, where source IP address is going to be this fellow, destination IP address is going to be the mobile user, and you will be sending the data to this guy. So either you will send to your ALG component, or you will be exchanging the user traffic directly like this, just through the router. That is your operator's implementation choice. So we won't be determining that on any other factor. It is on the basis of operator's implementation. Is this thing clear for you? Are you understanding it?
Yes, sir.
Hello.
Yes, sir.
Sir, up to the P gateway it is understood, but after P gateway you explained that there will be one router and router will terminate the call to another user. So is the user one making IMS call, or he is making
Rahul,
he is just using
Rahul, repeat
internet?
your question plainly. Can you speak closer to your mouthpiece?
My question is my question is, where is the IMS network in this example?
In which example? In the
You
example that I have
explained
told
that
you,
if
IMS component is only
if
for signaling, Rahul. It is not for user data. It is to only establish the SIP sessions. It won't be going through IMS. If you, okay, I will explain it to you in different way. Just hold on to this thought, you will understand. There is a user agent client, which we called it as UAC in SIP environment. There is a SIP proxy, outgoing proxy. There is another SIP proxy, which is an incoming proxy. There is another component here called as user agent server. Now, when the SIP signaling messages are generated, because you don't know the user agent server's IP address, you are sending the SIP invite method to outgoing proxy. Outgoing proxy is finding out the IP address of incoming proxy with the help of DNS, forwarding it to incoming proxy. Incoming proxy is finding out the IP address of user agent server from the register, local register, forwarding the invite method to user agent server. Once the user agent server replies back, it will come like this. Once these two, user agent client and user agent server, gets to reply with each other and establish the voice call, they will get to understand each other's IP addresses. After the IP addresses, they can exchange the user traffic directly. Just because the user traffic is going directly between them by using the IP network utilization, you are calling that these two buggers are not using the SIP environment. These two guys are cheats. You are calling them the cheats. Same way, You are telling me now that just because I have told these two mobile phones are only using LTE environment to exchange the IP packets from one another, the voice data from one another, you are calling this IMS network is useless. This IMS network is not bloody doing anything at all. You are telling what is the use of this IMS network. IMS network's use is when this guy is initiating the call detail must arrive to P because this guy don't know this guy's IP address. So he will be sending that information to P. P will send it to S. S finds out the IP address of this guy, and based on that IP address, the SIP session invite method must be sent to this fellow. That means SIP signaling is happening through IMS. That means IMS is helping you to establish the call. After the session is established, how do they exchange the user traffic is based on the implementation. You don't need to send that user voice traffic sending between these two users through the IMS network. You don't need to do that. Same way like here, your proxies and registers are your SIP network. Right? We are not using the SIP network to send the voice traffic. We are exchanging it directly between these two components. That doesn't mean that SIP network is useless and you cannot say that you are not understanding what is the role of SIP network. SIP network is establishing you the call. It is creating the required call for you. Is that clear? You have any follow-up question?
Means IMS network is only useful for signaling purpose. For user
I
data,
never said that.
uh,
I never said that. I said that it is optional. IMS network may be involved, may not be involved. Again, you are contradicting yourself because I have already told you this buddy PCSCF can be acting as a ALG component. Okay. If you look into the log file that we have studied, you will understand. So after the call is established, um, you remember the IP addresses of each of these users. One mobile user's IP address is 1.1, the other mobile user's IP address is 111. After the call has been established and it is acknowledged, 200 OK and acknowledged, your voice traffic started flowing between the users. How the voice traffic is going? 10.255.1.1 is the source IP address for the voice traffic. Destination IP address is 10.0.0.100. Who is 10.0.0.100? 10.0.0.100 is the proxy. 10.0.0.100 is not the other mobile phone. So the voice traffic is not directly getting generated from source IP address as 10.255.1.1, destination IP address as 10.255.1.11. If these two users would have exchanged the voice traffic directly without involving PCSCF acting as a ALG component for storing a copy, that time the IMS network won't be involved in the user data. The data will be exchanged directly between the user to user, and it will come maximum to P gateway. From P gateway, it will go back to the other mobile user. It won't be entering into the IMS network. Are you understanding it? But here it is entering. Why? Because I'm involving ALG component. I'm making the P gateway, sorry, PCSCF acting as a ALG component here.
okay, sir. Okay, got it. Got it. No.
Okay. So when mobile users are initiating the SIP sessions, any kind of SIP sessions, the entry point for the mobiles or the user agents is always going to be your P, the entry point for mobile users. Whenever any IMS network is receiving calls from any external IMS network, the incoming entry point is going to be I for when the calls are originated by the users which are present in other networks, visitor networks, or some roaming networks. From there, if you want to reach to this network, the entry point is going to be I. From I, it will question the HSS and then enters into S. S already knew the IP address, and the call invite method will be sent to the UE. That is how it works out. To understand that ALG mechanism, you have to study the call flow document I have sent in the SIP. We have a direct IP transferring examples. Lot of examples are direct IP transferring examples from one user to other user without involving any mediators. But there is exactly one example where ALG is involved, where traffic is being sent through ALG. ALG is advertising its IP address and port number to the other guys to receive the traffic copy in the middle actually. Yes, if you install four applications, then you will have to provide your when application has requested for you to provide the username and password or maybe email ID, mobile number, etc. You need to provide it and prove that you are actually that user with that ID. You may get a OTP or whatever, and you input that OTP, and then with that it will be completed. With that OTP, it will be completed. So once you logged into this application, the actual story starts. Application logging in is can be happening with your HTML protocol stack or any other protocol like XML. By using such kind of protocols, also application logging in can happen, or PHP data sending. By using such kind of protocols, they will perform the logging mechanism into the applications. But logging in may not be equivalent to your SIP. When you are opening, for example, you are opening Reliance Jio My Jio app. To log into the My Jio app, you just clicked on My Jio, which is not logged in yet. You can see some option called as sign in. The moment you click on sign in, it asks for your mobile number, you provide it. It asks for the OTP, you provide it. This information that is getting exchanged with the MyGeo server, maybe through HTTP. But after you logged into this application, if you are performing any kind of service related activities, those things might be happening with the help of SIP. Those things will be considered as sessions. If you're logging in, maybe session may not be a session. Okay, so logging in maybe, for example, um, if you use Facebook web page, if you log in into Facebook, Facebook might be using HTTP or HTTPS to send your username password information to Facebook server and getting your reply whether you have logged in into that Facebook application or not with your username password. It will tell you if you are logged in, you will be logged in. Your home page will be shown to you if you are allowed to log in. All this is happening through HTTP. It is not happening through SIP or whatever. But inside the Facebook, if you are decided to make a call to somebody, maybe that might be happening through the SIP. Or in case of Facebook, they will be using a proprietary protocol. But if we use your IMS applications, we'll be having SIP related invite methods that will be generated there. In
Sir,
LTE, voice can't. Sorry.
sir, actually, if you're using let's say that the HTTPS or something Google application or Facebook application, from UI side, if you
Pranay,
take IP,
I'm pretty
yes,
sorry,
sir.
Pranay, but I'm actually not getting your voice very cleanly at all. So,
Okay, okay, sir.
can you type
It's
your
audible, sir.
question? Yeah, yeah,
Okay,
try it once. Try it. Speak.
sir, if you're using that Facebook application or typing Google services, which is the source IP and which is the destination IP? Means it is going through means IMS network. Can means we can consider that PCSF IP will be that
PCS SIP is always the destination IP address because you never know what
destination
is the
IP.
destination's IP address. You will always be. That is why
Okay,
SIP is not a network level routing protocol. It is application level routing protocol. So definitely it should
okay,
be PCSCF's IP address will be the destination for any SIP invite method that you generate. And PS to
Okay, that
CS,
means
I'll come to it, Jitendra. We'll discuss that PS to CS. Okay. So we have completed half of our IMS network part. So these many components, we know what are they doing. Application servers providing some additional multimedia services provided by the operator, and HSS is for storing subscriber information and providing it to the component called as SCSCF. SLS is to help out to detect which HSS is storing your subscriber information. P is the entry point into the LTE network, IMS network for the mobiles. ICSF is the entry point from the IP multimedia network. ICSF is the entry point if the calls are arriving from the other network, or if the calls are going out of our network into the other network. It goes to the I here in the other network. Okay. Now the next set of things. Yeah, Rahul.
hello. Sir, there are many applications in internet. So, how to decide which application will go through IMS network and which application will go through normal internet?
That will be dependent on when the application is
Suppose
installed.
if I am using YouTube,
Wait a minute. When the application is installed, you will know whether the application is a IMS based application or a internet based application, because when you try to log in into that application, it will have to find out the server and complete the login. So once you are finding out the IP address of the server of that application, if that IP address is pointing to IMS network addresses, if it is not a public address, if it is IMS network address, you will know that it is a IMS application. So when the applications are installed itself, your mobile equipment can recognize which applications are internet based applications and which applications are IMS based applications. For example, all your Reliance Jio and equivalent applications will be IMS based applications. It will be trying to, they'll all be trying to send invite methods towards the IMS network if you do any kind of a thing on any of those applications. But when you are connecting to any of the internet based applications like Facebook, WhatsApp, etc., they will be connected to internet. The segregation will be there on day one itself at the time of installation itself. Okay, so depending on that, you will be able to find out. And moreover, when you are logging into any of these applications that are IMS based applications, you will be quoting your IMS based IMPU number there. You will be quoting your IMPU or IMPI. So based on that also IMS subscriber IDs you will be quoting. So based on that IMS subscriber IDs also your applications can be classified as IMS based applications. So it will be implementation choice. But ultimately, mobile equipment will be intelligent enough to detect whether it is a IMS based application or a internet based application, or to which PDN this application belongs to.
Sir,
Yeah, Proxima.
sir, I may misunderstood the spec, but sir, in spec it's mentioned during the initial registration time, I mean the IMS registration time, PCSF will send the register request to ICSF, and ICSF will contact HSS for getting the IP address of SCSF. After that, this authentication process will happen between the S and
That
SCSF
is in
and the
roaming
HSS.
cases. We'll study that roaming part. That is in roaming cases.
Roaming. Okay, I'll check that. Okay.
That is in roaming case. We'll go through that roaming scenarios and normal scenarios, etc. So we have multiple flows. We'll be studying all the IMS document. The full specification we'll go through. We'll understand those flows.
Okay, sir. Yeah. Thank you.
Even from this, what is the roaming? Even if you don't understand it, you can easily understand one concept here. So you can see that this P is not connected to I. Okay, so in the home network itself, P is not connected to I. There is no direct link between P to I. Do you see any link?
No, sir.
That means that P in one network is contacting I in other network, right? That is the only possibility, isn't it?
Yeah, correct.
Okay,
Yes, sir.
so that we will study again. What is that and when do we need it, etc. Is within the network, we don't have communication between P to I because P is the entry point for the mobiles, I is the entry point from the external networks.
Okay, sir.
Okay, so the next components that we are going to study are these four components which are in green color. These components are MGCF, Media Gateway, BGCF, and of course another BGCF is listed over there. So what these components are and why do we need those components? What is the purpose of it? Let us suppose this mobile is initiating a voice call, a SIP invite method. In the invite method, from address is his address, and to address is set to um, a SIP URI, which is the telephone URI. Um, it is set to a telephone URI. So when it is set to telephone URI, when the request comes to SCSF, it detects that this guy is making an outgoing telephone call. So the telephone call is a CS network user. It is a MSISD number. It has to go into your it has to go to these traditional ISDN networks, either your PSTN or PLMN. So what does yes do is yes will go and contact this BGCF, stands for border gateway control function, and this border gateway control function's duty is to allocate a pair of media gateway and MGCF for the purpose of dealing with the CS network to help out this user. Its BGCF's duty is only to select the a pair of MGCF and media gateway. So, what is the meaning of selection? BGCF might be aware that there are a lot of MGCFs and media gateways that are working in any IMS network, and this BGCF will be owning all those combinations of MGCFs and media gateways, and on the basis of load balancing and various other factors, BGCF will be selecting one pair of MGCF and media gateway to help this user who is making a outgoing CS call to an telephone number. So once the moment this guy completes the selection of MGCF and media gateway, he informs these details to the MGCF that hey, to help out so and so mobile, I have selected you to as a helper. You are going to get a message from the SCSCF, and the BGCF will respond back to SCSCF, and SCSCF will contact MGCF with the SIP invite method. From address will be the user's address. To address will be the telephone number, which is your CS network. And MGCF MGCF also will be acting as a signaling gateway, convert the SIP messages that it is receiving from one side. From his side, it will be receiving SIP messages. It will be converting those SIP messages into ISUP messages and will be pumping those ISUP messages into CS network. So this is ISUP messages. So this MGCF component is going to act as a signaling gateway to route the SIP calls into your traditional CS networks. For example, if you take that Airtel operator is having a IMS network and one user is making a Vivo LTE call, but he is making a Vivo LTE call to another user who is in the SIP network, or sorry, in the other user who is in the CS network. The other user is not present in the IMS network, other user is present in the CS network. So when the call is originated and sent to the yes, we will tell yes that this guy's number is a telephone number. So what does yes do? It will ask BGCF and get a MGCF and media gateway allocated, and from there the call details will be sent to MGCF. This guy will be contacting the CS network by sending ISUP messages, ISDN user part messages, by converting the SIP messages into ISUP messages. We will be sending it to the CS network. So that's the overall idea that uh, will be. So what is the duty of this MGCF component well, which is working as a signaling gateway also. Its duties is to convert one type of protocol messages into another type of protocol messages, vice versa. If we receive a alert message, alert is a SS7 protocol message. Once we receive alert, that alert will be converted into ringing in SIP messages. It will be converted into ringing. So, and we'll be sending it to S to UE. It will be traveling like that. And what is the duty of this? What are the other duties of MGCF? This MGCF will go and communicate with the media gateway, find out the media gateway's IP address and the RTP port number. It will find out the UDP port number for receiving the user traffic. And by packing those details into the SIP message, it will be sending the SIP 200 OK reply to UE. And similarly, MGCF will ask the media gateway to accept the establishment of a circuit with the CS network to receive the voice traffic. So on this side, we are going to have the circuit for the voice traffic. This is going to be RTP based interface to receive the voice traffic from the mobile to this media gateway. So mobile's IP address and port numbers will be forwarded to the media gateway. Media gateway's IP address and port numbers will be forwarded to UE. Of course, by using SIP signaling, we will be forwarding each other's IP address. So UE will route the user traffic to media gateway, and the media gateway will be routing its voice traffic to UE, whatever it receives from the other side. Similarly, MGCF will communicate with the media gateway and tell him to create a circuit with the CS environment. So a circuit will be both directions. So media gateway might have to link this circuit data to this RTP UDP IP traffic. So your IP traffic on one side we are using circuit, on the other side we are using IP traffic. So, and the duty of the MGCF media gateway control function, one more duty is the meaning of MGCF media gateway. So this component is called as media gateway. It is controlling function. It is controlling the media gateway. In which way? It is telling the media gateway to accept the establishment of a circuit on one side, IP traffic on the other side. It might also tell the media gateway that, hey, you might be receiving G.729 codec on this from this direction. You have to convert into PCMU codec on this direction. And if you receive the PCMU voice traffic, you need to convert into G.729 and send it to the mobile, because mobile is working on the latest voice codec. And when the voice codec traffic arrives at media gateway, it might have to shift that voice traffic into the old codec type, pulse code modulation codec type, and transfer it to the landline phone or a mobile phone which is present in the CS network. Here CS network represents your ISDN network. It could be a PLMN network, or it could be a PSTN. We don't care. Both will be considered as a CS infrastructure. Okay. So now, if if the user, if this guy is Airtel user, Airtel IMS user, and we are making a voice call to Airtel CS user itself, then the call will go to B. B will be selecting our own MGCF, our own IMS networks, MGCF and media gateway, and MGCF will be leading the call into Airtel CS network. And job is completed. We don't need the second BGCF. But if you are making a voice call by being a Airtel mobile, you are making a voice call to Idea CS network. Then the call will go to S. S will be sending it to B. Instead of B selecting this IMS network's resources, B will be forwarding the call to other B. This B, other BGCF is present in a other IMS network. In your like for example, in our example scenario, it is BSNL's BGCF network. That BSNL's BGCF network will be selecting one MGCF and media gateway in their IMS environment, and from there the calls will be routed to the CS network. So if the customers are identified as our own customers, but the guys who are present in the old network that belongs to the same operator, we will be using our own IMS networks, MGCF and media gateway components. But when the user is identified as an external user to our operator's network, BGCF will not be allocating MGCF and media gateway to deal with the CS network. Instead, BGCF need to forward it to other BGCF who deal with the CS network of the other operator. So we are forwarding it there. So BGCF to BGCF, the SIP details, SIP call details will be forwarded.
Sir, if other operator don't have that IMS network, then how that BGCF will present?
Any component is a BGCF. Basically, your gateways are going to be acting as the BGCF. So after it goes to BGCF, how it goes to the CS network, we don't care, but it goes to the CS network. Operators need to maintain at least one gateway to receive the traffic from external networks. They will be maintaining such a gateway for sure. They will be maintaining it. For example, BSNL must be maintaining gateways to receive the call from Reliance Jio operator. So they must be maintaining a gateway. That gateway is going to be called as a BGCF component.
Sir,
Yes.
it's the same related question only. Scenario. Actually, we are converting like means these are the CS network. Means some government organization like collectorate office. We have there maybe PSTN phone. So means we have short codes like 1077 for collectorate or electricity 1912 services.
All these protocol
So we have
messages will be converted by the
yes.
media gateway control function.
Media gateway only. Because we are taking that NGSet cost code, ISO cost code. As per that cost code only, we are routing to like the TAS and NGSet routing. So because only that asking some conversion we are taking because I'm making that ECJ data and implementing to that means coordinating to the software only. And what that conversion is happening in SCCF and in
No,
NGCF.
not
So
in SCCF. SCSCF won't understand other protocols other than SIP. It can only deal with SIP protocol messages. Its duty is only to forward it to the components responsible. So these gateways must be doing that conversions. SCSCF is not responsible for that.
but some conversion issue I'm facing there only for that SCCF conversion because when we are implementing that
Sorry,
whole
Pranay.
ECJ data.
Pranay, your
Yes,
voice
yes,
is like it is
yes, yes.
overlapping on the same voice. I'm getting some kind of a echo
Okay,
in your voice. I'm not
okay,
cleanly listening to your question at all. Can you type your
okay,
question,
okay.
whatever that you're asking, please?
Okay, sir, I'll call you because I could not able to type
No,
everything.
it would
I'll
be
call
helpful
you.
for others also if you can just
Okay, okay,
spend
okay,
some
okay,
time and type.
okay,
Yeah.
okay, sir. Okay, sir. It's audible sir, right now.
Yeah, you can type it. We are continuing this session. We are not yet done.
Okay,
Please
okay,
type.
okay.
You can download this document if you wanted to understand RFC 3666. You can download it from internet. If you want to understand how the calls will happen from SIP environment into ISEP, so you will be able to understand the complete conversions. So we have Alice, which is generating the invite method. From proxy to it is sending it to the NGW, which is your gateway. The gateway here is doing the conversion from SIP signaling messages to ISUP signaling. The equivalent ISUP message for the invite method is IAM message. It is done by gateway. It is not being done by the proxy. Your SCSCF and PCSCF will be considered as proxies or registers. They are not the gateways. So their duty is only to forward the calls to the other side and facilitate the call forwarding. The proxies functionality is only that much. But on the other hand, your gateways will be responsible for conversion of one protocol message into another. So invite method is a SIP protocol message. IAM is a ISUP message, ISDN user part related message. So it is being sent, and when the other phone is ringing, it is sending ACM message. So that is the when the other mobile sent a GSM message to, for example, if you take that it is a GSM call and the other guy sends alert, that alert message will be converted into ACM. ACM is a SS7 message again. When the ACM comes to the NG gateway, N gateway here, which is converting this ISUP message again back into SIP signaling, which is 183 session progress. So that 183 session progress will be forwarded. Once the traffic call has been established, both way RTP media has been established or one way voice has been established, you will be answering the call with 200 OK acknowledgement, and the actual voice traffic will be exchanged, and then by you are sending. You can easily now do the comparison with what here by is going to be equivalent to release, which is ISUP message, and in ISUP we have a response called as release complete. So here we will be calling it as a 200 for that buy message. So this release complete equivalent thing here is 200 OK. Like that in um, s- uh, various PSTN procedures, in case of PBXS, how the call flow will happen, what are the messages in different components in case of PBX call. So what is the message, ISDN messages we will be using. So like that, all those things are explained to you in this document. If you are interested in SS7 learning and if you are interested in learning the switch side sections, you can download this document and you can read through. Okay, so I don't want to go into it because we have not spent much time and learned the SS7 part. But if you guys are interested in SS7, I encourage you to download the 3666. The document that I have sent you is 3665. The next document is 3666. Download it. This is all going to contain the calls from SIP environment into PSTN, public switch telephone network call flows entirely.
The same thing actually. Sir, it's audible because it's typing is much more lengthy. That's why it's audible right now.
Yes, go ahead.
Yes. Actually, that means suppose a softcode is there, like softcode 1077 is there. Okay, so that PSTN maybe we are using PSTN or 2G or 3G handset for the vigilance officer something. So basically, I'm implementing
Handsets
that
will come
ECG.
into handsets will come into play after the
Yes.
messages will go to your exchange, nothing but your MSC or GMSC. Then the actual handset related things and where the handset is, whether he is in a 3G network or a 2G network, that segregation will happen after the call. At least will reach up to MSC. Up to that time, it will be considered as pure ISDN network. We don't bother whether the user is in a 2G network or a 2.5G network or a 3G network. We don't care in all those things. And the user is present in the
So
CS network.
okay, so same issue if you want to resolve, how can you take that ISO touch code means that NGSF CDRs, how can it help for that same thing? Because if I'm taking that NGSF CDRs, so how can it help? If it's PSTN number, it's okay. I can go through that postcode and whatever that routing issue or something, we can implement it. But how can for that it's a mobile? If there is a mobile direct number, mobile is if this is using for
If
a
what
vigilance.
is the number? How do we care? How it is the number? What do we care about? I am not. First problem I'm facing is your questions are not clear. Okay. Anybody understanding the question?
Okay.
Can somebody repeat it? Anybody getting this Pranay's question? Can someone repeat?
Okay, sir.
No,
Uh,
Pranay, not you. I'm asking someone else who have heard your question properly. I'm asking them to repeat it.
No, sir, it's not audible properly.
okay.
Anyone
Let
else
us
who
take
have
time.
heard that question properly? Okay. Nobody is actually. If you
So
can,
I think
yeah.
Pranay, Pranay should speak little slowly so that his words can be understandable. He is speaking too fast that his words are overlapped. So that is why we can't understand what he's asking.
I don't know. It is not that
Okay,
speed. It is
so
device issue majorly. So his device or any something
maybe
else may
sir.
be the problem. Uh,
So, okay, sir. Okay, sir. This question may be solved right now only because
okay, you ask it later. Otherwise, you type it. Okay, one of the thing you do it. Okay. So without understanding, for me to tell the answers, it will be very difficult. Okay. So we have we have these four components to deal with the CS network related communications. So four components we have in this place. And then we have three more components to study. These three components, what do? There is a MRB, media resource broker, and a media resource function controller, media resource function processor. What these components are and why do we need these three components? What is this purpose? If the mobile user is, if there are, let us take that three mobile phones are there. If they wanted to establish a conference call, but they don't want to do the media mixing themselves. If they want a media mixer, then the call will come to yes. Yes will recognize that there is a need for these mobiles to, for the purpose of a media mixing, we require one media processor. So in such cases, yes will go and ask media resource broker that, hey, guy, media resource broker, can you please, one of three of my users would like to establish a conference call. For that purpose, they require some media resource function processor. Can you please allocate somebody? So then media resource broker will be allocating a pair of media resource function controller and media resource function processor units for helping out these three mobile phones into the conference. So when these MRFC and MRFP comes into the play, what these components will do? I will explain. Let us suppose that when these three guys are establishing the conference call, the call related details will go to MRFC from every user, and MRFC will be providing, will be taking their RTP IP addresses and port numbers by himself, and it will be sending MRFP's IP address and port number to these three mobile users. So it will be telling this mobile MRFP's IP address and port number, same way to this guy and same way to this guy. So MRFC will control the MRFP, ask him to create three different port numbers, provide these three different port numbers and IP address details to three different users to receive the calls from these three different mobiles. And the MRFC, the media resource function controller, will tell the MRFP that, hey, you are going to receive the voice traffic from these guys. You are going to do the duty of media mixing. For example, if these two mobile phones are fighting with each other, they are talking at the same time, you will be getting the voice data from both the guys at the same time. You need to merge these two voices and you need to send to the third guy to the UE. So the UEs won't be exchanging the voice traffic directly from one another. Instead of it, UEs will be sending the traffic to this MRFP component, media resource function processor. It is processing the media resources. Whenever this word media is used, you can understand that it is related to user plane. So these MRFP is the actual component who does that kind of activities, and on the other hand, MRFC is to control this MRFP, explain MRFP that you are going to get G.711 codec from this guy, you are going to get G.729 codec from this guy, you are going to get maybe PCMA codec from this guy or AMR codec from this guy. Each guy already is having working on a different codec format. What do you need to do is convert all of them into one common format and send it to them in their own formats, in their own understandable formats. That kind of heavy processing also can be done by MRFP when multiple users are trying to establish the sessions with one another. For example, let us take one more simple example. If these two UEs wanted to establish a voice call with one another, they are going through the SCSCF for establishing the call. But after this guy sent the 200 OK, they come to a realization that they are not even supporting a same type of codec. So this user is having different codecs and this user is having different codecs. Even though both are having advanced codecs, there is not even a single common codec available between them. So when there is no common codec available between the users, immediately SCSCF will take the responsibility with the help of MRB. It will be getting one MRFP and MRFC resources, and by communicating with them, so we will be able to create the link between this UE to MRFP and MRFP to this UE, and tell the UE to the MRF, tell the UE to send the traffic to MRFP, tell the MRFP that hey, you received G.711 codec from this fellow, and the other guy can only understand G.729, convert into G.729 and send it to the other mobile. And if this guy sends G.729, convert it back into G.711 and send it to this fellow, because both these guys are not even having a single codec available between each other, we have to take the responsibility of converting the one codec type into another codec type data. So that's the way this MRFP is going to help us out. Okay, so that's the MRFP, MRFC. So in any kind of a media processing we require, we can bring this MRFP and MRFC. So what is the duty of MRP? It will maintain maybe combinations of lot of MRFCs and MRFPs in the IMS network. It will note down which combination of MRFC and MRFP are doing what kind of a jobs. And depending on the request generated by the users, you will be selecting the corresponding pair of MRFP and MRFC to help those user agents. We will be selecting. So that is the duty of MRB. MRB's duty is just a selection. It'll select the which combination couple is going to help you out, and those components are going to help you out. Basically, we can have some complex scenario also. For example, there could be two users who are in a conference call with a landline phone CS network user, a conference call with this guy, two UEs. How the SIP signaling will happen is like this, and it will go to yes to B to M, and finally it will go to CS network. The call details will come back, and your voice session has been established, conference call has been established between these three guys. But what about the user data? We'll order both these mobiles as these guys are in conference call. Media mixing should happen right now. So we should tell the UE to send the traffic to MRFP. We should ask this mobile also to send the traffic to MRFP. What does MRFP do? It will do the mixing of these two voices if these two guys are speaking at the same time, and that mixed voice will be sent to media gateway. From the media gateway, we will be pumping the traffic on the CS network on your what do we call it, on the circuit. We will be forwarding it to this CS network, and vice versa. If this guy speaks anything, it comes here, and from there it will be sent to this MRFP. And for example, if this guy and this telephone user are speaking at the same time, from the telephone the traffic will come to media gateway to MRFP. From this user the voice traffic will come to this MRFP. These two guys voice will be merged and it will be sent to the third guy. Okay, so on this guy's IP address and port number. So these these two guys are sending the traffic on IP technology to the MRFP, and MRFP to media gateway also we might be using IP network, but media gateway to external network or CS network we might be using circuits. So it can be any kind of a complex scenario. So signaling will typically happen through the signaling components, and these are your user data processing components. This your MRFP and as well as the media gateway both will be dealing with user data processing. Okay, so the idea is user data can be direct between one user agent client to other user agent server, or it could be through these components also. So the user traffic can be direct, or user traffic can go through MRFP come back. It can go to, if PCF CSCF is acting as the ALG, it can go to PCSCF and come back. So it can be any of the scenarios. It depends on the implementation and how you want to bring up your network, or depending on the situation. If UE and this UE don't support same codec, we must use MRFP's help to convert one voice codec type into another voice codec. There is no choice. They cannot directly exchange the user traffic because they don't support a common codec.
Sir, if there are three users and all are using IMS network, then also their voice codec will be different.
Can be different. I'm never told
Can
you
be
that it
can
could must be different. There is a difference between must and can. It can be different. Uh, but
uh,
mostly, what is the point is, in very rare cases, the mobiles will contain different codecs because most of the companies who develop the modern mobile phones, they will be developing similar kind of a codecs. So this kind of a mismatch won't be there. But sometimes it can happen. For example, MRFP need not be only used for voice codecs. You should not be thinking it only from voice codec point of view. You have to think it from all media angles. What is the meaning of all media angles that you have to think about? It is a simple mechanism. For example, this mobile and another mobile, all the three games are these three mobile phones are playing a PUBG game. For example, let us take it as a PUBG game or PUBG kind of a similar game. As these three guys screen inputs are arriving to a application server, for example, if application server can actually take the screen inputs and it can match the screen input of all the three guys and decide who is going to be killed and who is going to be winning. Okay, so application server can decide it. Or what application server can do is, application server only may be involved in establishing the game between these three users. Application server may bring in, and by talking to MRB, it can bring in one MRFC and MRFP to do your game mixing, game screen mixing. So the game screen mixing kind of functionalities can be done by your MRFP component. So instead of application server doing the job, you can make MRFP do the job to do the screen mixing of all these three mobile phones and decide what will happen in the next frame, in the next 1 second or next 1 millisecond. We can decide that. So it is okay, so it is something like that. So you cannot just imagine, when IMS network is there, you cannot just imagine that I this MRFP is only for voice calls converting one codec into another codec. It could be implemented with a lot of different uses. For example, this MRFP can be acting as a IMS networks what do we call it as playing service, player service. What is the meaning of play service? For example, you have tried to invoke a SIP session to SCSCF. SCSCF decided that this guy doesn't have the balance available anymore and you need to do the recharging. So it will go to MRB and it will get one MRFC MRFP, and it will go to MRFC and tell the MRFP that, hey, please play that voice record which explained to the mobile that his voice balance is out. So once the session is established, it will be established between MRFP and UE. This guy is only going to be working in send only operation. It will be sending the voice data which tells the UE that, hey, your subscription is out. Because you did not pay the money yesterday, your subscription time is over, your calls will not be accepted, so you please complete your subscription, then only your calls will be continued. That kind of a voice record can be played by this guy. So this, you can determine what kind of a media functions you want your MRFP to be playing. You can determine that. That's ultimately your choice. What do you do? What do you want to do with your MRFP? You can implement the MRFP in any which way that you want. Okay. Um, okay. The question that Pranay wanted to ask is, if you are using short codes like 1077 or any emergency numbers, then how the conversion will take place? That is the simple question. Simply, what will happen is UE will send it to P, P to S. Yes, responsibility is to detect that it is a telephone number, and it need to forward that basically to your B. B will be going into MGCF, and MGCF will be sending into CS network. If at all any conversion is taking for that 1077 into a landline number or into a mobile phone number or whatever it is, if it has to lead to that, that conversion must happen within your CS network itself. Whichever components responsible for doing that kind of conversions, like global title translations, GTT functions in the CS network, only those components will be performing this kind of conversions. SIP or IMS network is not responsible for that until and unless we have a support called as IMS emergency implemented into it. So there is called, yeah, there is a mechanism called as IMS emergency. When there is IMS emergency calls, IMS emergency services implemented, yet along with your SCSCF and PGCF, there will be some extra functionality included to be able to determine this emergency number that you have dialed is a telephone number at SCSCF itself. You will be able to determine whether this emergency number that you have dialed, is it a telephone number or is it going to be a SIP or IMS based number. Depending on that answer that you are getting back, your SCSCF will be able to determine whether the call should be routed back into the IMS network or the calls must be routed into the CS network. If IMS emergency is implemented, but there is no guarantee that the IMS emergency is implemented. You got it?
Sir, sir, we are using that emergency service for only for 100, 108, like 112. These are the emergency services we are using. And these short codes,
Any other
softwares we using.
non-ISDN numbers also, you have to do the same job. Concept is going to be similar. Only components mapping database will be bigger. That's it.
Okay, and one more question, that zero means zero permanent and plus 91 permanent. What is that? And that a digit modification something is there. So what is that?
Again, I did not get it.
Means zero zero means that zero one permanent means BSNL. If you are using that to implementing that software, so somehow some issue is coming, like BSNL is not taking that permanent, like a zero or plus 91 permanent. So can I please explain that zero or plus 91 permanent?
Okay, I will answer this question maybe later. Okay,
Yes.
so we will
Yes.
complete this part first, Pranay. Yeah.
Okay, sir. Okay, sir. Okay.
Facing difficulty in understanding. Okay, the last two components will complete them out. Transition gateway and IBCF. So these two components are for security purpose. This IBCF is to implement instead of SIPs, instead of SIP, if we wanted to use SIPs, we need to involve this IBCF, especially when the signaling messages are coming from the external network, or when the signaling messages are going into external network. Then we will be involving the IBCF to convert the SIP messages into SIPs messages for the security purposes. So your signaling message security will be taken up by this IBCF component, inter-border control function, we call it as. So this is for security purposes. It is acting as a presentation layer. Same way, this transition gateway that we have here in the middle, so this guy's job also is to is to provide the security for your user data. So if any user data that need to be encrypted, that data will be encrypted and then it will be sent into the IP networks if it need to be encrypted. So your voice data encryption will be taken up by transition gateway. So your signaling message encryption is going to be taken care by IBCF, and your voice traffic encryption is going to be taken care by transition gateway. That too, when the voice traffic is getting exchanged between one UE to another UE, where both the UEs are present under two different IMS environments. Within the IMS environment, typically we will be exchanging the traffic directly because it is internal to the operator. Operator will not need to maintain any extra additional security mechanism in his own environment. But whenever it is going out, you may require to do that. If any such additional security presentation layer activity is required, we will be bringing in this transition gateway. So these two components are needed in case of security, the secured mechanisms for signaling and user data part. Otherwise, we don't need these things. Okay, so what is what? The IMS control components responsible for these are like entry points. This is the actual decider. These are databases. These are user agents, and these are for CS network. And if you want to implement any media services like playing the records or doing the media mixing, any kind of such activities, or converting one type of media into another type of media, in such cases we'll be using the services of MRB, MRFC and MRFP component. And for security purposes, we'll be using this transition gateway and IBCF. IBCF is for control plane security, and transition gateway is for your user traffic security. So these are the primary components we have in IMS network. And if you see this slide also, we will complete with IMS network. So I have colored it. So what is this colored part? Wherever you see this aqua color, that is SIP signaling. All that is SIP messages. All these aqua color ones are SIP signaling messages. And wherever we have red color, it is diameter. That is diameter protocols. So towards HSS and SLF, we have diameter protocol messages. UE to application server, it is the user traffic, your UTP, RTP, IP traffic. And here also it is SIP only. Actually, this is missed. And we have MGCF to media gateway. We will be using a protocol called as H.248, called as Media Gateway Control Protocol, H.248.1. We'll be using the Media Gateway Control Protocol here. Even between MRFC to MRFP also, we will be using H.248, which is Media Gateway Control Protocol, because these two control components, either MGCF or MRFC, both are controlling media gateways and explaining them which kind of media should be converted into what kind of media. So both these control components will be controlling these processors, either the media gateway in case of CS networks or a media resource function processor in case of IMS network environment to provide additional media services. We'll be using H.248. And all these gold color lines that you see here, this is the user data part. going through the media gateway to the user, or user to transition gateway in case of security, or user to MRFP to media gateway to CS network, or any such things, are directly sending it from one IMS network to another IMS network, and or UE to this application server. This is all the user data going on top of RTP, UDP, IP, or any such equivalent thing, depending on what kind of a multimedia session that you are establishing. And this one is ISAP. This part is ISAP. Light aqua color is ISAP. ISDN user part messages between MGCF to CS network. And that is the protocols we have. So majorly signaling protocols are SIP and diameter, and MGCP, media gateway control protocol, between MGCF to media gateway, MRFC to MRFP. We use media gateway control protocol, and this is ISAP. And the rest of the interfaces are user plane, which is RTP, UDP, IP, or any other equivalent mechanism for sending your multimedia traffic. Either directly through the users, or if you require, we'll bring in media uh, function components like media gateway or media resource function processor. Okay.
Sir?